Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation for formulas on combinations and permutations. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoints in making this video series, and this is part 2 of that series. We are picking up exactly where we left off. I did not want to make a extremely long video, so I'm picking up just where I left off. I kind of cut off in the middle of our example in the previous one. So our examples are, and we're going to find without using a calculator except to add, subtract, multiply, or divide. And notice that's what by hand means. It doesn't mean we're going to do long multiplications by hand. It just means that we're not going to do the permutation itself or the combination itself on the calculator. So let's look at them one at a time, and we will start with 9p4 or 9 permutation of 4. First, what does the formula tell us to do with the permutation? Well, remember that means we're going to have the 9 factorial on top and the difference 9 minus 4, which is 5 factorial, on the bottom. Remember that 9 factorial means that we're going to count down from 9, then 8, 7, 6, 5, 4, 3, 2, 1 on the top, all multiplied. And then 5 factorial means we're going to multiply all the numbers 5, 4, 3, 2, 1 on the bottom, and they're all multiplied. We could reduce those, and we can see that from 5 down to 1, those would all cancel. And yes, I know some of your teachers will not use the word cancel, but they divide out and cancel. And that would leave us then 9 times 8 times 7 times 6 and give us 3024. But if these numbers are large, we do not want to have to write out all of the factorials. Remember, one of our examples had 100 in them, and we would not want to have to write out 100 numbers. We will redo this, but this time we will not write out all of the factorials. We'll use a technique that's very common when doing factorials. Again, 9 pick 4, but this time, in the formula, 9 factorial over 5 factorial, but this time we're going to match the factorials. We will count down the top, but just till it matches the bottom factorial of 5 factorial. So the top becomes 9 times 8 times 7 times 6 times 5 factorial, and we will leave the 5 factorial on the bottom. Then we can cancel out the 5 factorial with the 5 factorial, because we're not just canceling out a 5, but we're actually canceling out the 5 times the 4 times the 3 times the 2 times the 1. That again just leaves us 9 times 8 times 7 times 6, and still gives us the answer of 3024. Now it's time to look at letter B. B has much larger number, but it's actually a shorter problem. First, the factorial form of the formula, remembering to put 100 on top, and the difference 100 minus 3, which is 97, on bottom, both with factorials. So we have 100 factorial over 97 factorial. Then we want to count down the top until it matches the bottom. 100 times 99 times 98 times 97. And I notice now that she's left out the times in that last one. If I can, I'll slide it in there, but it may look a little different. That's why. The 97s then will cancel out, and we will be left with 100 times 99 times 98, which like I said, is shorter. We only are multiplying 3 things, and that multiplies to be 970,200. Let's do 100 combination 3. Remember, for the combination, we still put the 100 factorial on top. 100 minus 3 gives us 97 factorial, then the 3 factorial. On the top, we're going to count down till it matches one of the factorials. Think about it. We don't want to match the 3 because that's a long way to go. We want to match the larger one. We will only be able to cancel one of the factorials in the denominator. The other factorial will need to be written out completely. So we will choose to cancel the 97 factorial because it's the longer factorial. So we will write 100 times 99 times 98 times 97 factorial over 97 factorial. Then we write the 3 factorial out completely. 3 times 2 times 1. The 97 factorials are canceled, and we have 3 times 2 times 1. And we get 100 times 99 times 98 over 3 times 2 times 1. 3 times 2 times 1 is 6. 100 times 99 times 98 is 970,200, which gives us 161,700. There are a couple of ways that we could have done that differently. We just used Mrs. Borlaug's method: multiply the top, multiply the bottom, and then divide. Next, we're doing permutations and combinations, and to remember those differences between the two. The permutations, we have no repeats allowed. Order is important. That's for permutations. No repeats allowed. Order is important. For combinations, no repeats allowed. Order is not important. And remember your two formulas. Notice as we compared those two problems, which of the two is the smaller number, 100p3 or 100c3? Well, 100c3 is smaller because order is not important, and we will have a smaller number. Permutations will be larger, combinations will be smaller. Look at the formulas. Notice that when we divide by that extra 3, it makes our answer a smaller number. That's another idea which may help you remember which formula is which. Here is some student exercises for you to try. And again, it's about at the 8-minute mark here, or 9-minute mark. So I'm going to conclude here, and I will make the next video and close this one out here, and I will begin the next video. And our next topic will be on why these formulas work. Thank you for watching, and as always, Walter State students are welcome to drop by the Math Lab in MBSS 222.